Children, say in this particular sum, there are two circles intersecting at point O and X. Point O and X, two circles. Okay. Next, they are given B dash X dash C, means it's a straight line. X lies between B and C. Next, chord BZ of the larger circle and chord CY of the smaller circle, they intersect externally at point A. Now, to prove that, can you see a quadrilateral here? AZOY. I have to prove this particular quadrilateral is cyclic. Okay, so once again, two circles intersecting at point O and X. B dash X dash C means it's a straight line. Chord BZ and chord CY intersect externally at point O, and we are supposed to prove quadrilateral AZOY is a cyclic quadrilateral. First, with respect to larger circle, if you see, points B, X, O and Z, do they lie on the same circle? Is it right? So can I tell quadrilateral B, X, O, Z is cyclic? Now, if this is a cyclic quadrilateral for the larger circle, you might be knowing exterior angle of a cyclic quadrilateral is congruent to adjacent opposite angle. So can I take this thing as A degree and this here as A degree? So I can write angle AZO is equal to angle OXB is equal to A degree. This is exterior angle of cyclic quadrilateral congruent to adjacent opposite angles. Congruent to adjacent opposite angles. Is it correct? In the same manner, if you see the smaller circle, point number 2, with respect to smaller circle, see here, points X, C, Y and O, they are lying on the same circle. Am I right? So I get one more cyclic quadrilateral. Quadrilateral CYOX is cyclic. Correct? In this cyclic quadrilateral, again, there is an exterior angle at this end. And this exterior angle should be congruent to adjacent opposite angle. So if I take this thing as B degree, even this has to be B degree. Correct? So I will get angle AYO is equal to angle OXC is equal to B degree. Again, reason is same. What is that? Exterior angle of a cyclic quadrilateral is congruent to adjacent opposite. Point number 3. The secret is in this particular part. B dash X dash C, that means it's a straight line. Are they adjacent angles? Okay, so now measure angle OXB plus measure angle OXC that is nothing but A degree plus B degree. It has to be equal to 180. So I'll write it as linear pad x0. Okay. So now, point number 4. Let's enter inside this quadrilateral, the topmost quadrilateral, that is AZOY. In quadrilateral AZOY, measure angle AZO plus measure angle AYO is equal to AZO was A degree plus AYO was B degree. This I am getting from 1, 2. But children, the value of A plus B is equal to 180 we have proved in statement number 3. Therefore, fifth point, therefore, measure angle AZO plus measure angle AYO is equal to A plus B, that is equal to 180. This I got from statement number 4 and 3. Now please check AZO and AYO. Are they opposite angles for this particular specific quadrilateral? And opposite angles, if you're adding, it comes to be 180. That means opposite angles are supplementary. So can I write hence quadrilateral AZOY is a cyclic quadrilateral because opposite angles are supplementary.